Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at 3 papers. One of them is the guided notes called Introduction to Area, Perimeter, and Circumference. We're also going to look at a worksheet called Thinking About Area, Perimeter, and Circumference. And last but not least, we're going to be looking at our formula sheet. For those of you in my classes, my formula sheet is pink, my worksheet is white, and my guided notes will most likely be orange if I use the same color each year that I teach this. So, let's start with the guided notes called Introduction to Area, Perimeter, and Circumference. What you can see here is I created a chart here with the concepts of area, perimeter, and circumference. And it's important that you understand the difference between these concepts. For example, area is the number of 1 by 1 squares that fit inside of a two-dimensional shape. This is why the units of measure for area are square units, square inches, square feet, square miles. The way that we show that is we put a little 2 in the corner of the unit of measure. That's our way of saying inches squared, kind of like second power. Another way of saying that is squared. So that's how we show square inches. Likewise, square feet, little 2 in the corner. So this is what you want to pay attention to for units of measure of area. Now, perimeter is the distance around the two-dimensional shape. You can find that by just adding all the outside edges of a shape. That's going to be regular units of measure, regular inches, regular feet, regular yards, and so on and so on and so on. Circumference is also the distance around a shape, but it's specifically the distance around a circle. That's also going to be regular units of measure. All right, so let's now shift gears to the worksheet called Thinking About Area, Perimeter, and Circumference. So we're going to start with the second page. I know this is a little out of order, but we're going to start with the second page with problem number 8. Let's take a look at this together. It says use the information below. The average cost for installing a concrete driveway in Alice's City is $4.85 per square foot. Her rectangular driveway will measure 100 feet by 24 feet. What formula will be used? Now that's referring to your pink formula sheet. And how do you know? All right, so if you pull out your pink formula sheet, can you figure out, based on what this problem was giving you, which formula from that formula sheet is going to need to be used? Well, let me point some things out to you. This is a rectangular driveway. So we need to go to the formula sheet where it gives us the rectangle. But on your formula sheet for the rectangle, you're going to notice that there's going to be an area formula and also a perimeter formula. Which one do we need? Well, there's some stuff in this word problem that gives it away. 2 things. We are installing concrete. Concrete should fill up the entire driveway. And we just talked about how area is the number of squares that fit inside of a two-dimensional shape, and concrete goes inside of the rectangle. It doesn't just go on the outer edge of the rectangle, it fills up the entire rectangle. So that's kind of a big clue that we're going to use the area formula. Now, don't underline that on your formula sheet, but you can write that down. There's another reason why this was going to be area. If the price is $4.85 per square foot, only area could be in square feet. And so that's another reason why number 8 is going to be the area formula, specifically of a rectangle. And then obviously you just have to write that down. If you haven't done that, feel free to hit pause in the video. If you already wrote down the reason, then let's just move on. All right, problem number 9. I would like for you to read this to yourself and then try it on your own. So hit pause in the video, answer this question on your own, then hit play when you're ready to see how you did. All right, so let's take a look at this together. If you didn't do it on your own, you better hit pause now. We are talking about a circular swimming pool. So we immediately go to our formula sheet and we find the circle. But which formula do we want? Circumference or area? Well, we got to pay attention to what this problem is asking us to find, or what it's talking about. It's talking about putting fence around the pool. Now, you don't fill the pool with fence, you fill the pool with water. The fence goes around the pool, and it just so happens that the distance around a circle is the circumference. And that is why we need the circumference formula for this problem. If you need to hit pause to write down the explanation or to fix your answers, please feel free to do so. Otherwise, let's go ahead and move on. Back to the guided notes. At the middle of the page, of the first page, has special relationships that you need to know, starting with base and height. Follow along with me as I read this out loud to you. The base, called B, and the height, called H, will always be perpendicular to each other. Now, if you don't know what that means they will intersect at a right angle. A right angle is normally shown as a little square in a drawing. You'll see what I mean when we look at some examples on the second page. Now, please note, the height is normally drawn as a dashed or dotted line. Now, there is one exception to that. If the height happens to be one of the sides of the shape, and you'll see what I mean when we look at some examples here, then it wouldn't be a dashed line. But otherwise, most of the time, height is going to be drawn as a dashed or dotted line. Now, there are some specific things to know about bases of a trapezoid. In case you don't remember, a trapezoid is a four-sided shape that has one pair of sides parallel to each other. Now, parallel is not the same as perpendicular. Perpendicular is intersecting at a right angle. Parallel means the two sides go in the exact same direction and would never intersect each other. Now, the two sides that are parallel are called the upper base, which is called B1, and the lower base, which is called B2. Now, these are not exponents. This is not multiplication. It's just a numbering system, base 1, base 2. Now, we're going to go to the second page so you can see some examples of what in the world I'm talking about here. First, let's talk about examples of drawings where we have to identify the base or bases and the height. We'll start with triangles. Now, let me make something crystal clear to you. The base is not always going to be at the bottom of the drawing. Now, I know traditionally, especially back in elementary school, the base was probably at the bottom. It's probably one of the ways that you identified it. But we know that you can take any shape and rotate it so that the base would no longer be at the bottom. And so with that in mind, we have to be a little bit smarter than just looking for the bottom. We need to look for the right angle, as I have highlighted here on my screen. Why? Because we just learned that base and height will be perpendicular. They will intersect at a right angle. So on this first drawing, you can see here's the right angle. So there's the base, there's the height. Notice the height is a dashed line. But on this drawing here of the right triangle, the second drawing I have here, the height and the base meet at a right angle. Notice the height now is actually the left side of the triangle. That's why it's not a dashed line. Now, on the third drawing, I took the triangle and I rotated it from how you would normally see it. And so this is why the base is now on the right and the height, which is that dashed line, meets the base at a right angle. And that's how this drawing would work. So the bottom line is always look for the right angle. Height and base always meet at a right angle. Height is normally a dashed line, but it won't be if it's the side of the shape that meets the base at a right angle. Now you can see also examples of this with parallelograms. Again, look for the right angle. Remember, the height is normally going to be a dashed line, and the base will be touching that height at a right angle. So it's not always at the bottom. You can see the examples here. Now, a special parallelogram where all four sides are congruent, that is called a rhombus. You might remember that from previous years, but now I'm just refreshing your memory. Trapezoids. All right, we read about this on the first page. A trapezoid has one pair of sides that are going to be parallel to each other. And those parallel sides will be the bases. We'll have B1 called the upper base, or sometimes it's called base 1, and B2 called the lower base. So you have to be able to identify the pair of sides that are parallel to each other. It's not always going to be at the top and bottom. As you can see on the example over here, this third drawing, well, actually, I guess that one is on the top and bottom, but kind of diagonal. But this last example, notice the parallel sides are on the left and right side. The height then would be this bottom side because it meets the bases at a right angle. Actually, at right angle at both spots. So, with trapezoids, four sides, but only one pair are parallel sides. The parallel sides are your bases, and then whatever touches those parallel sides at a right angle is going to be the height. Again, often it's drawn as a dashed line, but it might not be if it's an actual side of a shape, as you saw here on this example here and this example here. All right, so with that in mind, let's go back to the worksheet, thinking about area, perimeter, and circumference. On the first page, but near the bottom, problem number 6, what shape are we given? Well, you could look at the second page of the guided notes that we were just looking at. You could also look at your formula sheet. This is a parallelogram. How do we know? It's a four-sided shape. Both pairs of sides are parallel to each other, but the corners don't make right angles, so that's why it's not a rectangle. And so that's how we know it's a parallelogram. If I go too fast, feel free to hit pause on the video at any moment to write things down. Now, what's the basis value? What's the heights value? How do you know? Well, we've talked about how with base and height, they always meet at a right angle. So the base will not always be at the bottom. I know it is here on this drawing, but over here in the second drawing, the base was on the right because we see the dashed line for the height touch that base at a right angle. So back to the worksheet. Well, that's what we have here. Here's the right angle. And we know the height is this dashed line. The base touches the height at a right angle. Well, with a parallelogram, the right side is the exact same measure as the left side. And so the 94 centimeters is actually the measure of the right and left side. And since the right side is definitely touching the dashed line at a right angle, this is how we know 94 centimeters is the base and the dashed line is the height. Again, if I go too fast, feel free to hit pause in the video, write things down. Part C, if you were finding the perimeter of this shape, what value would not be used? All right, you have to go back to the first page of the guided notes. And when you do that, you're going to see a reminder on what perimeter means. It's the distance around the two-dimensional shape. So that's only going to use the outer edges of the two-dimensional shape. So back to our worksheet. The outer edges are the 94 centimeters, and there's two of them, and also the 63 centimeters, and there's two of those, the top and the bottom. So what value would not be used? Well, the height, because the height is not an actual outer side of the parallelogram. And this is something you need to know about perimeter. Perimeter does not normally use height unless the height actually happens to be a side of a shape, which normally it's not. Normally it's a dashed line. So perimeter is only going to use the outer edges, which is why on this drawing, it's not going to use the 55 centimeters. All right, problem number 7. This might be on the back of the worksheet if I'm remembering correctly, second page. I would like for you to try this one completely on your own. There's a part A, there's a part B, there's also a part C. So hit pause in the video, try number 7 on your own, and then once you've done A, B, and C on your own, then hit play to see how you do. All right, I'm going to go over it. So if you have not tried it on your own, you better hit pause on the video now. Part A, what shape is given? How do you know? Well, ladies and gentlemen, this is a trapezoid. Now, it's not your traditional drawing of a trapezoid that you would see on the formula sheet. But since it's a four-sided shape, and the left and right side are the two sides that go in the same direction, that's what we call parallel sides. But the top and bottom are not parallel. They don't go in the same direction. This is why it's a trapezoid, not a rectangle or parallelogram. Part B, what's the values of B1 and B2, and what's the height? How do you know? Well, did you go back to the trapezoid backside of the guided notes? Remember, the B1 and the B2, they're always the parallel sides, and the height will touch the parallel sides at right angles. So it just so happens the parallel sides are the 7.5 and the 6, so that's your B1 and your B2. It doesn't matter what order you write that in. And since the 7.9 is the side that touches at right angles to the bases, that's why that is your height. Yes, on this one it wasn't a dashed line. I told you before, sometimes the height can be an actual side of a shape. Got to look for those right angles. Now, part C. If you were finding the area of the shape, what value would not be used? Okay, you got to go to your formula sheet where we have the traditional drawing of the trapezoid. If you find the formula on the formula sheet, it's 1/2 times height times B1 plus B2. That's the area formula on our formula sheet. And there's one measurement, and it's the 8.04 that would not be used. And here's why. The 8.04 is not the height, and it's not the bases. And only the height and the bases show up in this area formula. Well, also a 1/2. So the 8.04, not the height, not the bases. That's why it's not going to be used for the area of the trapezoid. All right, I'm going to go ahead and stop this video, and I'm going to do the remainder of the guided notes and the worksheet as a separate video. So thank you for watching. We'll see you next time.